All right. Good afternoon, everyone. My name is Madhu Kashyap. I work for Netsia. My colleague Mesut, also from Netsia. And we'll be talking about ONAP orchestration for multi-access edge cloud. Quick look at the agenda. Why multi-access edge cloud? I think we got a lot of good background this morning as well. Orchestration as the key control point for the edge cloud, and then what we are doing, our experience with the ONAP, and where we are going with the ONAP for multi-access edge cloud. So quick background, last year World Economic Forum came up with a report that said digitization will unlock $1 trillion in value. And they made the point that broadband is sort of the lifeblood for this digitization. This huge number, this is a key infrastructure for the digital society. And as you can see, there are a lot of national broadband initiatives across different countries. What you can see is mobile broadband growing tremendously, 1 billion users of 5G by 2023. And also fiber is growing rapidly and quickly overtaking other copper and cable technologies. So today's consumer is demanding faster access, and IP trends are increasing. The IP networking is increasing. And so what we are seeing is initiatives by vendors, by operators, to expand the scope of broadband, both mobile and on the fiber side. So looking at access networks, and this morning again we had keynotes and plenary sections on access, but there are a lot of challenges on the access network. Today we have both wireline and wireless on the access network on the central office. Lots of high OpEx, CapEx, you heard from Deutsche Telekom and AT&T and so on. Vendor lock-in issues, operational issues, and the issues with how do you monetize these access networks? How do you roll out new services? So these are all challenges faced today by operators. And so what are they doing? You heard this again. They're adopting these new technologies, SDN, NFV, cloudification. These are themes that you've been hearing today and over the next few days. But they're really looking for a set of hardware and software that can flatten their network. A single management domain for the access, whether it's wireline, wireless, doesn't matter. A set of management tools, configuration tools that reduces your access network to a single management domain. And so what you're seeing is this adoption of open source, white box, cloudification, SDN, NFV. So the traditional central office is evolving. So what you're seeing is things that were on the customer prem is moving towards the edge cloud from one end of the spectrum. Firewalls, IPS, NADing, VoIP, they're all moving to the edge, towards the edge. So you're reducing the cost on the CPE, as well as from the core cloud. Again, this morning you heard of OMAC and COMAC and some of those tools moving towards the edge cloud, a virtualized EPC. So you're seeing the evolution of this edge cloud from a very traditional central office. And so what Netsia is looking at, and with SEBA and COMAC and so on, is to use SEBA as the underlying substrate, where whether you're on a residential, broadband, business, or mobile, you're connected through a PON network to your central office, to your edge cloud, together with a global orchestrator, which is part of what we are looking to provide to operators. So the real value for this multi-access convergence, just to recap, and then I'll hand over to Mesut to talk about how ONAP fits into this is the SOX, cost savings from a single management and orchestration domain, the rollout of new services, disaggregation of basically mobile and broadband components, common data user plane and control plane. Right. So there will be thousands of edges, central offices that will be evolved into these edge clouds. And so you do need an orchestrator to orchestrate applications, VNFs, configuration, a lot of the FCAPS information that is needed here. And so we are looking at ONAP as a global orchestrator.
Thank you, Madhu. My name is Mesut Soyturk. I'm working for Netsia as a product development coordinator and mostly engaging with the SEBA development activities. I will talk about our journey with the multi-access edge orchestration for the ONAP. Actually, we are investing in ONAP since the first release of Amsterdam came up to the ecosystem. And we experimented all ONAP releases and use cases up to now. And within our strategy, ONAP will be the end-to-end orchestrator. And we will use the ONAP as a centralized monitoring of access edges, where Netsia multi-access platform runs, which I will talk about a little bit in the upcoming slide. And we believe that the integration point with the OSS, BSS systems within the IT infrastructure of the operator will be the ONAP. And we will leverage the ONAP to configure and manage the Argela product solutions. So as Madhu mentioned, Netsia is now working on the platform we called Netsia Mac, multi-access telco at the multi-access cloud at the telco edge. And this platform is about the multi-service, multi-networks, as well as augmented some advanced slicing capabilities. This whole platform, of course, orchestrated by a global orchestrator. So from end to end, anything we are using, building, are based on open source and open platforms like white boxes and so on. Netsia Mac platform is based on ONF's Connect solution. You can think that Netsia Mac is the commercial available version of the Connect. So on the left-hand side, as you can see, there's a device edge, and there's wired, wireless, and IoT devices, end-user devices that is connected to the network. And all, in a typical scenario, today they are connected through the different access technologies, which is end up with the different IT infrastructure in the operator ecosystem. And so this is inefficient. So what we do, we actually connect them all through a single passive optical network for maximum efficiency. That means they actually use a shared OLT to reach the services at the global, at the operator core network. All of these different devices will use the same exact infrastructure and same passive optic network and the same OLT and same the data center. The Netsia Mac platform will be the common base platform for our solutions, which is SEBA, vRAN, and DSFC. I won't talk about the DSFC, but this is the dynamic service function chaining application, which utilizes the Trellis and the ONOS, which we already made some trial tests in the Turk Telekom data center with integrating with real PNFs and with integrating with the PCRF, and which utilizes the VNF and PNF functions. And SEBA, we already heard about it in the morning sessions. I have a couple of slides about the SEBA and the vRAN solution, radio access controller that Netsia works on it. So this picture depicts that our vRAN solution. It's actually we are working. I mean, we are part of the ORAN solution, and we are leading some application parts on the ORAN side. And the primary feature of our program application is allowing the operator or the network owner to control the radio access, radio resource management dynamically, and on the wireless access side. This gives the operator the ability to virtualize and slice the E node B with the virtualization features of the E node B. The operator can control the utilization and monetization of the E node B devices. We integrated this solution with ONAP, and not only ONAP, with the OSAM Mano as well. Actually, you can onboard the complete vRAN solution remotely using VNF and VNF descriptor and network service descriptor configurations, and that you can restart, stop, and reboot the vRAN program application. Also, you can initiate the program application at the beginning, which you allows to deploy a program from the global orchestrator. So we talk about. I mentioned about the slicing. Also, we see that there's a run slice manager, and we see that there will be a slice manager for the transport network as well. And this will be, this should be managed globally, and we will use the ONAP as an end-to-end network slice manager to manage the end-to-end slices that is required by the users. Actually, this is the POC. We demonstrated this POC in many events, and lastly, we collaborated to the ONF during the MWC, and we integrated our ONAP closed-loop solution with the ONF's Connect platform. Actually, in this solution, we have program UI, which you can configure the slices from the remote end, and you can, using the program UI, you can configure the program controller application, and you can create the dynamic slices. So program UI is running on the ONAP platform, and UI application sends its operation request to the program controller with leveraging the SDNC and the CC SDK, which is part of the SDNC project, that you can create some configuration. Additionally, this use case shows the closed-loop functionality to configure the slices automatically as the end user demands more bandwidth while he is watching any video or any content from the core network. A local application collects the current statistics of the end user and sends it to the DCAE using the WES collector. And we are analyzing these events by using DCAE, and we create some policy rules by using the policy framework and HOMS framework. And according to the demanding slice request, we can increase or decrease the end user bandwidth slice configuration. So on the SEBA side, we are part of the OSAM project. OSAM is like OSAM is like an EMS system for the SEBA. And during the architectural phase of the OSAM project, we thought many use cases and how can we integrate the SEBA through the ONAP. The one major idea was to integrate deeply with the ONAP using each ONAP component. But as you may be aware, SEBA is fully container-based, and ONAP cannot onboard for now, the container applications. And we decided to have SEBA represented as a simple PNF function to the ONAP. And we took the 5G use case approach, which was proposing the PNF approach. You can easily onboard the PNF functions to the ONAP, and we choose the PNF approach for the OSAM project. And we simply created this is a high-level architecture, basically. And there's an OSAM core, which interacts with the OSS, BSS systems. It's running like a VNF function in the ONAP architecture. And there's an OSAM gateway. OSAM gateway is responsible to interact with the underlying SEBA function, and its role is to register the SEBA ports to the ONAP as a PNF function. So, for the future direction, here is the picture that we are working on it in our SEBA development. In the classical PON network, there will be 100 ports that will contain the SEBA deployment, and maybe thousands locations for the OLT devices. But there will be a few central management ports that will reside in the operator data center. And in our solution, we call it a SEBA central middleware. This is our solution, which is responsible to interact with the operator OSS BSS systems, which are CRM systems, provisioning systems, and inventory management. And beside that, also SEBA central middleware is responsible for the AppScapes functionality. So there's an integration point for the ONAP. You can easily use the ONAP common components to replicate these functionalities. So maybe you're already aware, there's a project, STNR, which utilizes the SDNC component, and STNR is fully responsible for the controlled radio access network. We believe now we are exploring that STNF could be developed for the fixed broadband access for the passive optical network. In this case, our SEBA solution, we will integrate it with the ONAP using STNF functionality. So this concludes my presentation, but I have a video for you. Actually, maybe I believe it will entertain you. That in video we show basically the idea that you can centrally manage the SEBA ports in the central offices. So, let me find it. Sound? No sound. We have deployments in the edge sites, and we have a central orchestrator which you can remotely deploy the SEBA ports to the edges. For this demo, only 2.
But geographically distributed. Yeah, nice.
How long did step 1 take?
Not really.
I see seconds. I see seconds.
The thing is, it does the installation remotely and then runs validation test suite automatically. Some automated test suite runs and validates the installation.
And you can configure the services for the subscribers remotely using the SEBA UI.
a service, no, it's not there yet. Yeah.
After providing the services to the user, we are checking the service flows and etc. Now we are providing the triple play services from the residential gateways.
And you're pulling FCAP's data off of the Kafka?
Yes. HSI, VoIP, and IPTV multicast.
So it's a triple play installation, all validated in the live network.
Yeah, that's all. Thank you for listening us.